2013 structural forms. This question does not require any tracing paper. What you will need to do for this question, the graphic on the right shows an uplighter in the form of a hyperbolic paraboloid surface. I'm just skipping this little bit. The surface of the hyperbolic paraboloid is generated by translating a parabola ABC, which is in plan ABC, in the horizontal position downwards along the parabola DBD. Okay, B is the vertex for the parabola ABC, and D is the vertex in the figure shown. It says in the elevation you have a hyperbola as well. Okay, so the focus and the vertex. So a hyperbolic paraboloid will have a hyperbola in one view and usually parabola in the other view. So in elevation we have two hyperbolas. So it's asking us first of all to draw the plan of the uplighter. So the plan essentially is all of these measurements down here. It's just this this parabola, and this again is another parabola, the exact same measurement earlier on. It's just been transferred up a distance. All of the measurements have been halved, okay, because the scale is 1:2, and off we go. Again, you've plenty of space to do this on your sheet, so I just need a height of 80. So just make sure that you have a height of 80 in order to actually complete that little bit. Okay, give a little gap and make sure you have the 90 underneath then. Okay, and do your construction lines. So I'm going to just double check those measurements now as well. Oh, sorry, that's a little bit too tall. So I am just going to double check. So I have 90 on the bottom, I have a space, and then I have 80 up on top. And I've drawn my center line. The overall width is 300, which means it needs to be an actual overall of 150. And that means 75 either side. There's a measurement of 60 in, which becomes 30. There's a measurement of 90, which becomes 45. And again, obviously the 30 on the opposite side, 1, 2, 3. So this is completely symmetrical. Transfer those up. Okay, so in order to do the plan, so it is just a parabola, we're going to divide the side into a number of places and the base into a number of places. 90, I think 150 goes, or 1.5 is nice spacing to get you 6 spaces. I'll just double check. Yeah, so I'm going to go with 6 spaces, each of them being 1.5 in measurement. So that's 15, 30, 45, 60, 75, and then 90. So that's 6 places on the left hand side. We're going to go for 6 places on the base. So we're going to use line division for it. Draw a line off at any angle, step the 6 places on it. And all you're doing is sliding your assessments. Okay, and keep doing it for each individual one. As this is the axis, all of the lines need to be parallel to it, as you've seen from every other question that we've done. And again, once you've done half of this, you'll transfer it over to the other side. B is your vertex. So these are going to the second vertex, those parallel lines. The points on the near side will go to the near vertex, which is B. First with the first, second with the second, and so on. Okay, now that I have all of my points, I'm going to transfer them over to the other side. Grab your compass in order to do this. I'm just going to make sure that that's in viewpoint. and draw your curve in. Okay, the curve up on top also means, okay, so it's the exact same parabola and it's moving out a particular distance. In order to get it, I first of all need to transfer the curve down its particular depth. You can use the tracing paper if you want to transfer the curve into that position, but we should be able to just take a particular height to transfer. So if I just draw a vertical line down, I'm going to do it in colour, till it touches the curve. Okay, so this point is now going to be there. So every point is moving that distance. So on the next line, if you take this distance on your compass and strike it from every point that we have on the base, we should find our new curve. Okay, so take that purple height, and from every point that we got on this curve, if you strike the distance, the new curve will find itself. And just make sure you have those line divisions actually in so you can see exactly where the coordinate will be. Okay, and you can redraw that curve in. If the curve has been moved up a particular height. Okay, now that we've that done, that's part A of the question done. Okay, and just to finish that off, I'm just going to put heavy lines just between the points A and C. So there's A and there's C, so I have the heavy lines drawn. Okay, project the given end view from the plan. So we know how wide it needs to be and we know how tall it is from the elevation. So bringing your points up at 45 degrees. Now you're probably wondering, what other point do you need to bring up? Well, you need to bring up where D is. So this point is D. So bringing it up across first of all and up at 45 degrees. And that gets you point D. To get the back edge, okay, so we have the height, and the height of it was 80, bringing up point B and finding B in the correct place. It was telling me that BD was also a parabola and D was the vertex of that parabola. All we need to do now is create the rectangle and bisect it as well. I just want to make sure or see if the distance is a nice measurement that we can use it. It isn't, so use line division again. Now the top of this was 80 actually, wasn't it? So I might use that as one of my measurements. Yeah, so I'll go for 4 spaces every 2. Okay, and because this is my axis this time, these need to be horizontal. That means on the side up here, I need to divide it up into 4. So draw a random line off at any angle, measure your 4 places on it, and transfer them back. Okay, and these ones are going to the vertex, which is D. Draw the curve in. Okay, and that is the end view done. Okay, just harden the lines for the bottom and the top. Okay, end view is complete. Part C of the question is project the front elevation of the lighter. So because it's a hyperbolic, that's a hyperbola, paraboloid. So we've done the parabola bit of the question. We now have to do the hyperbola. We were told in the question that when we measured in that 30, we got a vertex and the outside point is a focal point. Repeat this on both sides. And again, we're going to use the rectangle method in order to get the hyperbola. So I have this space on the left-hand side. What I'm going to do is, again, I'm going to use the same 4 heights up, so same 4 spaces on the outside. And it means I need to divide this little space up into 4. So up on top, I'm going to measure the 4 spaces. Actually, I'm going to do a slightly wider angle so I can fit 4 on my page. So 1, 2, 3, 4. Bring the last one back to the last point on the line. And again, I'm just going to double check that you can actually see that. So slide the set squares. Okay, so at this stage I have the 4 points on the top and 4 points on the side. The near points go to the near vertex, the far points go to the far vertex. So join near ones to the near vertex. And join the far ones to the far vertex. Okay, the first with the first, the second with the second, the third with the third, and then the fourth. Transfer the other side. The last part of this question is asking you to get the asymptotes of the curve. And I'm going to refer you back to a sheet that I gave you a couple of weeks ago, I suppose just before Christmas. When we were doing conics, I gave you all of the definitions of where the transverse axis comes from, where asymptotes come from, where the directrix comes from. And it's that sheet I'm referring to now. So part D of the question is asking you to, the curve in the elevation is a portion of a double hyperbola whose vertices are V1 and V2 and whose focal points are F1 and F2 respectively. You are asked in this question then to determine the asymptotes of the double hyperbola in elevation. And luckily I have that sheet just close by so I can go through the construction with you. Okay, so that's the elevation done. It told you it was a double hyperbola. And I'm referring back to these notes that I gave you a couple of weeks ago. The last page of the notes, and I'm just going to zoom in for you on this, refers to basically all the constructions around the double hyperbola. Now you can see the asymptotes are these blue lines and are essentially a tangent to the edge of the hyperbola that best suits the curve. Okay, there are 2 straight lines that best suit the curve. In order to get the asymptotes, given the focus and vertex, the vertex and the focus, you're going to put your compass on the center and you're going to rotate it up. And at the same time, you'll bring your vertex up vertical. And where the 2 points meet is a point on your asymptote, which goes to the center point. We only have half of this. So instead of it being an X shape, it's going to be a V shape. And I'm going to do that now. And that finishes this entire question off. It was a very, very fast question to actually do. So I'm just going to zoom back out so you can see my page. And I can do this construction for you in colour if you like, just so you can see it. But it's not really necessary. So your compass goes on the centre. I'll just do it hard for you, and then you rotate the focus up and you draw the vertex up vertical until the 2 lines meet. That is a point on your asymptote. And the asymptote goes through the centre of the transverse axis. Yes, you can just transfer this distance over the other side and get the V, or you can do the construction either. So I'm just going to do the construction because it is actually just a little bit faster. Okay, and both of those lines there are called the asymptotes. That is part D of the question. So at the moment, we've done parts A, B, C, and D of the question. That is it finished, and that completes structural forms for us.